Good evening to one and all. This is Aksha from the ECE department. Today we are discussing about Zener diode introduction. Zener diode is a semiconductor diode. Zener diode introduction. Zener diode is a semiconductor diode. Introduction to Zener diodes. Zener diodes are introduced by Meinl Zener. Zener diodes are special type of semiconductor diodes which are used to allow current flow in reverse direction when the specific voltage known as Zener voltage is reached. They are widely used in various electronic circuits for voltage regulation and protection. Zener diodes are very highly doped diodes. Basic structure of Zener diodes. Zener diodes are similar to regular diodes as PN junction diodes, and it are ensured to sharp breakdown voltage. The construction leads to breakdown mechanism that allows the stable voltage regulation. The physical structure is crucial for its function, influencing both formation and reliability. Zener diode mechanism. Zener diode occurs when the reverse bias voltage exceeds the Zener breakdown voltage, allows the current flow in reverse direction. We have two types of breakdown, Zener breakdown and avalanche breakdown. These two are different with each other, but they belongs to Zener only. The phenomena is result of quantum mechanical effects, where electrons gain enough energy to cross the band gap. The breakdown voltage is previously controlled during the manufacturing of making Zener diodes reliable for scientific applications. Characteristics of Zener diodes. Zener diodes exhibit a unique current voltage VI characteristics curve with a sharp breakdown region. The curve shows the relatively flat voltage across the range of current in the base of indicating scale voltage regulation. Okay, these characteristics make the Zener diode ideal for the voltage camping and voltage stabilizing applications. Zener voltage rating. Here we can see the circuit diagram for the Zener diode. Variable Vn. Vn is the voltage, inner voltage. I is the current. L is the load resistance. Load resistance are regulated when V input and V output. We can see here V input and V output. Voltage coming to the source, voltage coming to the diode, and voltage leaving from the diode. RL is the load resistance. IL, inductive load. We have three types of loads: capacitor, inductor, and resistor. Here we can see two types: inductor and resistor. Zener voltage regulator circuit. This is the Zener voltage regulator circuit. We have seen different types of parts here. Applications for Zener diodes. Applications where we can apply the Zener diode applications. We can, in our daily life, we are using stabilizers. Stabilizers is the thing which is used we use it to protect our mechanical and electrical instruments like TV, fridge, and these are protected by stabilizers. Stabilizers are used to control the current, where the current is coming from the source, higher voltages and lower voltages. By using these instruments, hence we can regulate the current. When we give the high power also, they can give the power which we want to take. This is the circuit diagram for load resistance, Zener voltage regulator. R is the resistance, Vs is the source voltage, Vz and Vij. We can see here Vz and Ij. This is a Zener diode symbol which we can see as Z symbol. Like PN junction diode contains a line, but we can see here like a Z type of symbol. RL is the load resistance. Next, applications: voltage regulation circuits. Voltage regulation circuit. In voltage regulation circuits, you can see here a circuit. It contains variac symbol. It contains varying voltage. Voltage is varying here. We can see that voltage is varying. The arrow mark represents voltage varies, and this is resistance is 10 ohms resistance, and Iz is the load resistance RL, regulated output voltage. This configuration is simplified at the effect, making the common choice in electronic design. Yes. Advantages of Zener voltage. By using Zener voltages, we have PN junction diode has so many limitations because PN junction diode cannot be used at high power things. It will be damaged at some high power is generated. Zener diode cannot be damaged and it is used in reverse direction also. PN junction can't used in limitations for Zener diode. Zener diode have limited power rating and cannot not overheat if the current exceeds their maximum rating. They are not stable for high frequency applications due to capacitive effects that can destroy the signal. Next, comparison with other diodes. We are comparing PN junction diode with Zener diode and other diodes with Zener diode. We can get some points. Stocky diodes, while faster, do not provide voltage regulation like Zener diode. This unique capability makes Zener diodes indispensable circuits requiring in-process voltage control. Conclusion: the Zener diodes are essential components in modern electronics, providing stable voltage regulation and protecting. Their unique characteristics and versatility make them stable for the variety of applications. Understanding Zener diodes is crucial for anyone. Next, thank you to all for listening.